So welcome back to another episode of Amazon Leetcode questions for the past 6 months. And the next episode is going to focus on jewels and stones. So let's just try that. So what this question is about, okay, and so the inputs are J and S. So J means jewels and S means stones, right? So the S comes in as a string, J comes in as a string. So S each character in S means a stone, right? And there's a difference between lowercase a and bigger case a. So you have to take this into an account. And your goal is to find how many jewels are in that stone. And how do you know if it's a jewel or not? So you just have this string also. This J means um, what are the jewels basically, and each character represents a jewel, right? Obviously, and in this case it means big A is a jewel and small a is a jewel. So with given that information, you just have to count how many jewels are in this bunch of stone piles, right? And this is a jewel, this big A is a jewel, and this big A is a jewel. So we have three in total. So all of these B are just a bunch of other stones that we don't really care about, right? So the answer is three. So for example, in here, we know that small z is a jewel, but in the pile of stones, there is no small z, so which means the count is zero. Okay, so there are a couple of ways of doing this problem, and I will show you both ways, basically. Okay, so the easiest problem is loop each character through S, which means stones, right? And then check if that character S is equal to any of the characters in J. So basically, this means it's a nested loop, right? So let's see what I'm talking about. So each stone in S, you have to loop again in J. And if S is equal to J, then you have to count the jewels, right? Not count, you add the jewels. So basically, you have to have a variable called jewel count of some sorts. And then in here, you just basically add by one. And then you just return jewel count at the end. And let's just run that code, and it is working, and voila, it's working. Cool. And also you can use built-in function of Python to do this. So I'm just gonna show you a little bit trick in here. Let's see. So you have to basically flip the loop. So each jewel in jewels, right? You just have to count the jewels in stones. So basically, there's a function called count in Python, and then you just do this. So from string s, which means the stones, you just have to count number of j's, right? And then you just add it to the count. This solution is basically exactly the same as the previous solution. It's just that I'm just using this count function that is in Python. So let's just run this. Yeah, it's working. Boom, it's working too, right? But this is a little bit slower than the last one. Okay, so is this the optimal solution? Obviously not, right? So this is like doing double loops, which means your time complexity is n times m. If I say n is the number of jewels and m is the number of stones, right? Because we have nested loop, we have um, multiplication of time complexity. And obviously space complexity is zero, not zero, constant, because we didn't declare any variables where it expands as much as s or j. We just declared one variable, which is just constant space complexity, which is just an integer, right? So we don't really count that. Okay, so what's the second solution? So the second solution, obviously, it should speed up the process, but in sacrifice of memory, right? So you have to store something in memory and then make the process faster. So we call that dynamic programming in, computer science terms, but I don't really want to get into that in this problem. Basically, what it means is you just have to remember your jewels, and then if you remember your jewels, you can just instantly tell, okay, this one is a jewel or not, that one is a jewel or not, right? So how do you do that? You do that by So let's just leave this joule count because we're going to use it. You do that by using a set in Python. And then you just do this. So basically what this means is every string in S becomes a set. And the output of this thing would be like, if this was the input, right? It would look like, okay, we have A, we have big A. And when this becomes a set, you can basically instantly check if some character is a jewel or not. So you don't have to loop through each and one of them to tell it whether it's a jewel or not. You just instantly click it, instantly say it. And then we call this like O of one lookup time, right? Insertion and lookup time, deletion, those kinds of things. And yeah, so that's the advantage of set. Now we have that in memory, you just loop through in every stone. And then if a stone comes in, is in the jewels, then we just increment like that. Basically, easy as that. And then run it. So it's working. And then, well, I mean, come on. I mean, it should be, theoretically, it should be faster than that, right? So if I submit again, it might be even faster. So submit again. Huh. Okay. I mean, this is kind of BS, right? But as you can see, there are like 16 millisecond runtime that I had that I did. But whatever. This Leetcode is not perfect because it has a service in the back end that can mess up the time, right? So as long as you're not in the 100 millisecond, like 10 times lower than that and stuff like that, so you're fine. But what we know is this thing, this loop is big O of, like, let's say n, right? N is the number of stones. And then this thing, like if statement, is constant lookup. So which means it doesn't add to the complexity. And in the end, what is the time complexity, right? So obviously, when you are constructing your um, set, you have to loop through each of the characters. So which means if I say the number of jewels is m, then this is the time complexity and this is the time complexity. So instead of multiplication, we just have addition, right? So the bigger picture would be m plus n. That's the total time complexity. And if you have done any of the time complexities in your school or in whatever, then this is just the answer of maximum of that. And obviously this is the time complexity. So what about space, right? Space, we have one variable that is expanding as much as j, so which means it's just m. So versus it was this before and then the other one looks like that. So this was the first solution, right? And then this is the second solution that we have. Obviously, the second one is much, much better and it's more sophisticated. We're using data structures to speed up the process and it's much more optimal. All right, that is it for this problem and see you on the next one.